Hello, so now we have an analysis and design of retaining wall. Here's the problem. Consider a cantilever retaining wall with the cross section shown, which supports 6-meter depth horizontal backfill with a unit weight of gamma s is equal to 18 kilonewton per cubic meter, and then the ground surface carries a uniform live load of 12 kilonewton per cubic meter. Allowable net soil bearing pressure at the base of the footing is 260 kilopascal. Coefficient of internal friction between the foundation and the soil is 0.7, and its angle of internal friction is 30 degrees. So for the unit weight of concrete, 24 kilonewton per cubic meter. Fc prime, 28 megapascal. Fy, 345 megapascal. And then use concrete clear cover of 75 millimeter. Use 28 millimeter diameter and also 12 millimeter diameter. Design the wall using NSAP 2015. So for the solution, so step number 1, we need to approximate the proportion of the retaining wall or cantilever retaining wall. Okay, so step 1, so we need to have our base from our lecture. Okay, so base width is equal to actually this one is 0.4 to 0.65, but we use the maximum, so 0.65 of h. Okay, so 0.65 of h is, so our h is 6 meters. Sorry, 0.65 of 6 meters. So this is 3.9 meters. And then for the thickness of the base, so for our thickness, it is from 1/15 of h to 0.1 or 1/10 of h. So 1/10 or 0.1 of h is equal to 0.6 meters. Then this for the stem of our stem thickness at the bottom of our cantilever retaining wall, let's say this one is our SB. So SB is also 0.1 of h, so 0.6 meters. Then for our toe, width of the toe, so width of the toe, this one, letter T, so T is equal to B over 3. So B over 3 is equal to 3.9 divided by 3, which is equal to 1.3 meters. Then for our ST, okay, so ST is the stem thickness at the top of the retaining wall. So this one, so ST is equal to 0.25 meter or 250 millimeter. This is the minimum size, so we use this 0.25 meters. So for step number 2, we need to check the stability of our retaining wall. So using our formula, so this one is a horizontal backfill. So horizontal backfill. So using our formula, Rankine coefficient of active soil pressure, so Ka, to convert our vertical loadings to horizontal. So we need this one. Ka is equal to 1 minus sine phi over 1 plus sine phi. So active tayo. Okay? So 1 over 1 minus sign and then 1 plus sign. So 1 minus sign, our angle of internal friction is 30 degrees. And then 1 plus sign, 30. Okay, so this one is equal to 0.333. Then now we need to convert our vertical pressure to horizontal pressure using this Ka. So we don't have water level from the problem, so we have only two pressure. The first one is from surcharge, and the second one is the soil pressure. For our surcharge, so P, let's say P1 is equal to Ka multiplied by Qs. So given our Ka and then multiplied by our Qs, which is applied here. So this one is equal to 12, okay, 12 kilonewton per cubic meter. I'm sorry, 12 kilonewton per meter. Okay, so uniform live load, okay, multiplied by 12. So this should be in kilonewton per meter also, meter squared also. Meter squared, you can use line load, so you can use kilonewton per meter squared, but the given is a surface, no, so it should be squared. So we apply the 1 meter strip later for getting the forces of our pressure. So this is equal to 3.996. Then for our soil pressure, horizontal, P2 is equal to Ka multiplied by gamma S and then multiplied by H. Okay, and then 0.33 multiplied by 18, then multiplied by 6.6. So this pressure, from the surface of the soil up to the below or bottom of the retaining wall, so 6.6. So plus the thickness, 0.6. Okay, so next is so this one is equal to 39.56 kilonewton per meter squared. Okay, so next is considering a 1 meter strip. So in the analysis, so our F1 now is equal to P1 multiplied by 6.6 again multiplied by 1. Okay, so here's our pressure diagram. Okay, so this one is for our surcharge, and this one is for our soil pressure, horizontal soil pressure. So this is our P1 value, intensity here. So uniformly distributed naman yan. And then this one is our P2. Okay, so to get the F1, so this is located here, so F1, and then F2 is located at least here now, thirds, no, 1/3 off from the bottom. So this one is F2. So F1 is equal to, so get only the area of the intensity. So P1 multiplied by 6.6 multiplied by 1 meter strip. So this is equal to 3.996, then multiplied by 6.6 multiplied by 1. So it is equal to 26.374 kilonewton. And then next for F2. So F2 is 1/2 of, so this one is 6.6. So 1/2 of our P2 multiplied by 6.6, our H, plus thickness of the base, then multiplied by 1. So 1/2 multiplied by 39.56 multiplied by 6.6 multiplied by 1. So this one is equal to 130.548 kilonewton. Then now the vertical forces acting on our retaining wall. So we have here first the surcharge. We need to get the resultant of the surcharge. So this one, and then the soil, okay, vertical forces. Let's okay, split this one, or the stem, into two. Okay, so let's have also this weight, then this weight here, and then weight, and then for the base weight. Okay, so we have here weight 1. So let's say this one is our weight 1, then weight number 2, okay, 3, then W4, then W5. Okay, so get the area, multiply by 1 meter strip to get the volume, then multiply by specific weight of the specified material. Okay, so W1 is equal to 1/2. Okay, so this is equal to this one is equal to 0.6. Okay. Then this one is equal to 0.25. So this is equal to 0.45. Sorry, 0.35. Okay, so 0.35. So W1 is equal to 1/2 of 0.35 multiplied by 6 meters. So 6 meters, then multiply by 1, then the specific weight, concrete, this one is under concrete, 24. So it is equal to 25.2. Then W2, also a concrete, rectangular naman to. So 0.25 multiplied by 6 multiplied by 1 multiplied by 24. Okay, so 36 kilonewton. And then W3 is uniform. Okay, so 12 multiplied by so this is equal to this is equal to 2 meters. Okay, from our assumption. Okay, so 2 meters. So base 3.9. Okay, so 3.9. And then this one is 1.3. Okay, so 3.9, 1.3 for our toe. Okay, then minus 0.6. Okay, so 2 meters for our width of the heel. Okay, so 12 multiplied by 2.0 multiplied by 1, so 24 kilonewton. And then for our W4, so W4 soil naman to, so 2 meters multiplied by 6 multiplied by 1 multiplied by 18. Okay, unit weight. Okay, 216 kilonewton. Then W5 is equal to concrete pa rin, no? So 3.9. Okay, 3.9 multiplied by thickness is 0.6, and then multiply by this thickness, then multiply by 1, multiply by 24. Okay, so this one is equal to 56.16 kilonewton. Okay. Okay, next, kunin na muna natin yung mga moment arms of those vertical courses. Kailangan kasi natin yan mamaya to determine the factor safety against overturning, yan, and overturning moment, tsaka writing moment, yung mga distances na yan. So let's have this one as our reference line. So from that point, pivot point natin, so unahin natin yung x1, so partner niya yung x or w1. Ito na muna. So x1, then x2, x3, then this one is x4, then x5. Okay, so simply x1 is equal to, okay, yan, x1 is equal to 1.3 plus 2/3 of 0.35. So lagay na natin dito. So x1 is equal to 1.3 plus 2/3 of 0.35. So 1.533 meters. And x2 is equal to 1.3 plus 0.6, then plus or minus minus half of the 0.25. Okay, so 1.3 plus 0.6 minus 0.25 over 2. Then x3 is equal to x3, okay, uniform live surcharge, the surcharge 1.3 plus 0.25 plus 1. Okay, so yeah, 1.3 plus 0.25 plus 1. And then x4 is equal to 1.3 plus 0.6 again, then plus, okay, plus again also, no, half of the width of the heel, so 1.0 also. Then x5 is equal to, okay, so 3.9 over 2. So 3.9 over 2. Okay, x2 1.775. Then 2.9. Also, this one is 2.9. So 1.950. Okay, so this is all in meters. So total horizontal load, kunin natin. F is equal to F1 plus F2. Okay, so F1 plus F2 is this one plus this one. So 156.922 kilonewton. Then total vertical load is equal to RV. So summation of W's. Okay, wala naman tayong external forces pa dyan. So W's. So from 1 to 5. So add mo lang tong mga to. Okay. So this is equal to 357.36 kilonewton.